In this video, we're going to talk about some characteristics that we find for our quadratic equation of f of x is equal to ax squared plus bx plus c, which we have learned how to convert into vertex form of a times the quantity of x minus h squared plus k. So let's talk about some of these characteristics. One of the first things we need to notice is that the graph will open up if the a value is greater than 0. Remember that when we're talking about the a value is greater than 0, that this just means that a is a positive number. So if it's a positive number, we know that it opens upward. And it opens down or opens downward when a is less than 0. And when we say a is less than 0, that just means a is a negative number. So that's one of the very first characteristics about our parent function, or our function in general, about which way it opens. The second thing is that we know that if you get the absolute value of a, that this is what we call a multiplier of our function, of our parent function, x squared. So remember that our graph will be a little narrower if the absolute value of a is greater than 1, because it's going to be a vertical stretch. Also, we know that it's going to be wider if the absolute value of a is some number between 0 and 1, some fraction. So we can see that it's going to compress it down towards the horizontal axes. The third thing we need to note is that we can find the axis of symmetry. So I'm going to write that down, that this is, the AOS stands for axis of symmetry. And the axis of symmetry will always be x is equal to h. In other words, if I have it in this format, that we're going to set that equal to 0, and then we solve for x, and we'll find that x is equal to h in this particular case. So I want to let you know h can be a positive or a negative number, but it's always going to be when we set that parentheses equal to 0. Or you don't have to have it in vertex form, and you can find it to be the negative b over 2a. And the negative b, it's this b that we're talking about, and this a, so the negative b over 2a. And you can always find that. Or you can stick it into vertex form, and then you know what to do in terms of finding h and k. Which leads me to the fourth thing we can find is the vertex. And the vertex is going to be at h comma k if we have it in this vertex form. So that's easy to find. Or, now this is where it gets a little ugly, but we can also find it when we find this x value here, negative b over 2a, and we plug it in to my function, whatever that number is, and that y value will be the y value of my vertex. So it's a little messier in terms of that. Let's practice this and practice graphing functions, quadratic functions, that may be either in standard form and we have to convert it into vertex form so we can answer some questions. Let's say our job is to graph p of x, where p of x is equal to 2x squared plus 4x plus 6. In order to graph this, we may want to stick it into vertex form. Before I do that though, one point that's really easy to find is if I let x equal to 0. So in other words, p of 0 is equal to 2 times 0 squared plus 4 times 0 plus 6, we can see that this is 0, this is 0. We find p of 0 is equal to 6, and this is 1 point on our graph, 0, 6. This is the y-intercept. That's the cool thing about standard form of a quadratic equation. It's really easy to find the y-intercept, but other than that, it's hard to graph. So we need to convert our p of x, which is 2x squared plus 4x plus 6, into vertex form using the completing the square method. So the first thing we're going to do is make sure we have 1x squared, and in fact we want to factor out whatever coefficient is in front of the x squared. We want to factor it out of the x as well as the x squared. So let's do that. So the first thing we're going to do is write it as 2 parentheses. I'm going to leave that plus 6 on the outside. I'm going to have x squared here, and when I multiply it, we can see 2 times x squared does indeed give me my 2x squared. Then we're going to figure out 2 times what will give me 4x. Well, that would be 2x, and we can do our distributive property. That gave us our 2x squared. This will give us our 4x, and the plus 6 doesn't need the distributive property because it's not inside of the parentheses. So we've done step 1. Step 2 is, now that you found that, go find h and h squared. And remember, the hint of the day is that h is equal to 1/2 of whatever's in front of the x. So let's go do that. Over here, I'm going to say h is equal to 1/2 whatever's in front of the x. And what's in front of the x is a 2, and half of 2 is 1. And we know h squared is 1 times 1, which is 1. So we've done that. Step 3 is the hardest part, which is to add h squared in our parentheses, and we need to subtract, because we need to undo it kind of thing. We need to subtract a times h squared on the outside. So let's see if we can do that. So we're going to bring down our p of x, and we're going to add our h squared, which was 1, inside the parentheses. I still have my plus 6. I'm going to do our multiplication of 2 times 1, and then I'm going to subtract it. So I'm going to have minus 2 out here. So I'm going to write that in blue, so remind ourselves where it came from. And then now our next thing we need to do is to factor what we have inside the parentheses, and it will factor to something squared. In fact, x and h will be in the inside, and you can do a plus or minus. It doesn't matter what the positive or negative h, as long as it's going to be h. And we're going to add the numbers that are on the outside. So for us, we're going to have 2 on the outside. We're going to factor this perfect square trinomial into x plus 1 squared. Remember, our h was a positive 1. That's why we have a plus 1 down here. And I'm going to add these two numbers. I get plus 4. So from here, we know that we can graph this using our transformations. So let's do that. Before I do that, let's make sure that we talk a little bit about what we know about this graph. We found before that we know the y-intercept. The y-intercept, I believe, was 0, 6. And we know that we have an a in the front, our multiplier. So it's still going to open upward. So I'm going to write everything we know about our parent function. We know that it's quadratic, so it has a little U shape. The plus 2 is going to make it narrower. We know the plus 1 inside, so I'm going to solve x plus 1 is equal to 0. I'm going to get x is equal to negative 1. That's going to be our horizontal shift. I'm going to graph that over here on our graph. This is x is equal to negative 1. And in fact, while we're here, I want to remind you that this is also the AOS, the axis of symmetry. It is that vertical line. So that's cool. Now that we know our vertical line, we also know that we find the vertex by having that same x value of -1 and our vertical transformation of +4. So I'm going to do that vertical transformation up here at +4. So we can see y is equal to 4, and we can see our new origin is here. Coming back to my parent function, we know our parent function is usually 0, 0, 1, 1, 2, 4, 3, 9, as well as -1, 1, -2, and 4. But we do have a multiplier of 2. So we're going to have to make sure that we multiply these y values times 2. So that 4 is going to become 8, that 1 is going to become 2, 0 will still remain 0, and we can see these numbers change. Okay, so now we're ready to graph. So I know that we have the point 0, 0, which means we're on our new origin, which is our vertex of -1, 4. For the next point down here, it says go over 1 and up 2. Normally we go over 1 and up 1, but we're going to go up 2 because of the multiplier. And then the next point is 2, 4. So I go to my new origin or my vertex, and I go over 2 and up 4. 1, oops, not 4, 8, because I got to multiply it times 2. So that's how I'm going to get 8. So 2, 1, 2, 3, 4, 5, 6, 7, 8. We can use our axis of symmetry that says, oh, if I went over 1 to the right for this point, I'm going to go over 1 to the left for this point. And I can see the same thing over here. I went over 2, so I'm going to go over 2, and we can see our parabola looks like this. Interesting. Interesting. So we were able to find our vertex. We were able to find our axis of symmetry. We know our y-intercept was the point 0, 6. My question is, are there any x-intercepts? Does it cross the x-axis at any point? The answer is no. We can see that our x-axis here does not have the graph touching it nor going through it. What that means to us, and we'll get more detail about it later, what it means to us is that it does not have a real, so I'm going to write that down, that there's no real solutions to the equation of, and I'm just going to go back to my standard form, general form. So that means that there are no real solutions to this equation. In fact, we're going to get complex or imaginary numbers. We're going to get complex solutions. I found that out just from the graph. And that concludes this video.